So in this video I'm going to have a look at the actual internals of Git. We've seen quite a lot of different things from commits and files and that sort of thing, and I'm going to have to show you at this point how Git manages all of these. So I'm just on the master branch on the same repository as last video. So I'm going to have to take a look at Git. The first thing you want to look at is the head file. So .git/head. It shows us what ref we are, what our head is. What we can do is check out to see how that changes. Pick any sort of commit. It'll tell us we're on the detached head state, and now our head has changed accordingly. Now pointing to the commit that we checked out. So we'll now go back and check out to moo. It'll show us that we're now in ref's heads moo. And if we go back to master, now our ref is ref's heads master. So what's that? You'd say, well, let's have a look. Git, we have this extra directory called refs. Then we have two possibilities, tags and heads. Now for tags, obviously, that's there. This is 2ab14, that's 2ab14, so that points to this. And there's also heads master. Now, heads contains two files, master and moo, which coincidentally are the two branches that we possess, and that contains this hash, which is an identifier for, indeed, this commit. So when I said that branches point directly to commits, that's what I meant. That's exactly what they do. They point directly to commits. So this should be a commit. Now we can use the show, for instance, to show that yes, so this is a commit, this merged then, and it's got these two, it's merging these two, and it's got this author and this date, and then it's got that message. But we can look at it in slightly more detail by going git cat file-p and see exactly what's in there. This is like show / format equals raw, but it's a bit more low level. So here's our commit exactly. We see these parents, so git lg, that's 40 and 02, so it's 40 and 02. There are two commits, and then there's this thing called a tree, but there's nothing here about what files were changed and how they were changed. There's this is all just the commit message, but there's nothing here about what we did. That's actually in there. This points to another object. Do cat file-p. That's another object called a tree object, and it contains all of the files in this commit. It actually contains these hashes and their names. So we can take a look at this, for instance. Well, let's have a look at the rhyme file. So we can git cat file-p, boom, and there it is. That's actually the direct file. So what we've seen so far is we've got our head, so that's our head, which points to a ref, right? That ref points directly to a commit. The commit has a parent, which points to a commit. Oops. It may even have multiple parents, another parent, there you go, another commit. And it has a tree there, that points to a tree thing there. And each of the tree sort of lines, each of the fields in the tree point to what's called a blob. That's a blob. And each of these links, well, this is not really, but this is a ref, this is a hash, this is identified by a hash, this is identified by a hash, these are all identified by hashes, and they're all stored in the same place. They're all stored in .git, so let's find this one. They're in .git objects ob89 0b89. Sorry, though. Did I do OB? Oh, so 0b89 blah blah. It doesn't contain it exactly. It's not a literal dump. That's because it's got some magic numbers in there and it's zipped and such. So it's not directly that, but that is where that file is located, and Git knows how to unpack that. So that's how that works. Another interesting thing that we can do, so let's make a little, where are we? Let's make a little extra thing, like so, just call it moos. So there's multiple moos. So echo move 1 to moos1.txt, echo move 2, moos 2.txt there, add moos. That just adds everything in that directory, so it tells us there's 2 new files. There we go, commit, that's 2 files in staging, added moos, there. So we've added those moos. There's something more interesting now. Cat file -p there. Something more interesting now, namely git cat file -p. We look at the tree of the current commit. We see that there's all these blobs, and there's another tree. That tree contains these 2 files that we just added. So what actually happens, so this can also be another tree. They can be blobs or trees, and that tree will point to another, just identified by a hash, by another set of blobs. That's actually how Git does directories. That's how it stores them. So each directory is turned into a tree containing multiple blobs or trees. And this is, all of this is identified by its hash, by its SHA-1 hash, and it's all stored in the same place. It's all stored in this object directory. Actually contains all of these prefixes. If you have a look at this, for instance, you can see that, for instance, let's pick a random 9f efa git objects 9f. That's the first 2 characters, and the rest should be efa 04 there, just to speed up a bit, because scanning through large directories can get very expensive. So there you have it. That's how everything is stored. Everything goes just into that .git directory, and there's a little bit more going on. For instance, inside the Git directory, you have this config file. In there, you can put local changes. For instance, if I do this, git config, change this. Just quick copy that. Oops. I don't like that. Just change that into git config. There, put that in there. Does that go like that? No, that doesn't go properly. So do that there. So change this to decamu local. I make a little change. Just make a little change. Hello to hello world. Right. Commit a-m. There. It's now turned into decamu local, and it hasn't changed our global configuration. So I can take a look at git config. I could, for instance, put these aliases or this conflict style, this merge conflict style, only activate them for this repository by putting them in that .git/config file. So if you're at work, if you're at home, working from home or something, and you normally do everything on your own sort of name, and then you're doing something for work where you need to have your work email in there, for instance, you can just change it locally. So stick them local. I'll take this out. No, actually, I'll leave that in. Shit, I already did it. Oh, Alright, well, never mind. I'll let that slide for now. So what else is in there? Well, there's a whole bunch of stuff in there. It can get... it's got lots of stuff that aren't really that interesting for us right now. And I'm sure if one of them crops up later, I'll get into them then. But right now, you know pretty much everything about how Git does things. You might think, okay, so if it literally stores all the objects in this directory, won't it explode the file size? Well, yes and no. Yeah, obviously, when you've got this, I'll have a look at this. Git cat file-p. Look at this commit and this commit. They have different trees. That's one tree. That's another tree. So these are two trees. They're mostly identical. One of them obviously has this directory added to it, and sorry, although it's not the moose, it has one thing different, namely we changed hello.txt, and by changing hello.txt we changed its hash. Obviously it hashes the entire file, and if anything changes, the entire hash changes. So most of this is still the same, but because the contents of this one file changed, it had to add a new file to its database, namely CE013, etc., which has the new contents, namely here, here. All the other ones could remain the same, but because this one changed, the hash of this tree changed. So it had to create a new tree object as well, updating the tree with just using this new this new hash for that one file. So it now has, I did one change for hello.txt. It had to update obviously a new commit, and it had to update a new a tree and all that. But what it does underwater, when you're working locally, most of the time you won't notice this, but what it does underwater actually, when you can do git repack, for instance, where it will compress itself. It'll start putting things in, for instance, in pack. It'll start packing things together. It'll actually take a look at all the files and see which files are like other files and create diffs between them, so it doesn't have to change the whole, store the entire thing, but can just change one original and then a bunch of differences between the files. So it sort of tries to compress itself. It usually only does this when you push to a remote location. And mind you, everything we've done so far in each video has all been local. This would be impossible in Subversion because you'd have to do everything via the remote server. So far in Git, every single thing we've done has been in the same repository locally. We haven't even used the network even. So anyway, that's about what I wanted to cover in this video. So that's how objects and such are stored, and that's where you can find them. So yeah, I hope you enjoy that, and I'll see you in the next video.